Okay, so on to question number 5. What makes the molecule SO3 nonpolar? So this is question number 5, yep. So to answer this question, let's first find the Lewis structure of SO3. So to do that, let's calculate the total number of valence electrons for a molecule SO3. Sulfur has 6 valence electrons, and oxygen also contains 6, and there are 3 oxygen atoms, so we multiply this by 3, which gives us a total of 24 valence electrons. So now we can draw sulfur as our central atom, and then draw 3 oxygen atoms symmetrically around it. And all of these oxygen atoms will have a double bond. And we can draw in all of the lone pairs on the oxygen. And sulfur is one of those atoms that is able to create multiple bonds. So in this case, there are like 6 bonds to the sulfur. And now let's find out its Vesper shape. So let me look up a Vesper table. Okay. And if we analyze our Lewis structure, then we can see that this structure contains 0 lone pairs on our sulfur atom and 3 bonded atoms. So using our Vesper chart, we can see that this corresponds to a trigonal planar molecular shape and electron geometry. So I'm just going to write trigonal planar. And you can see that this atom is also symmetrical. So now let's look up the electronegativity values of the atoms that are involved. So to find out whether or not an atom is polar or nonpolar, we want to find out the difference in electronegativity between the 2 atoms involved in the bonding. So in this case, we want to know the electronegativity difference between a sulfur atom and an oxygen atom. So the electronegativity of oxygen is 3.5, and the electronegativity of sulfur is 2.5. So this gives us an electronegativity difference of 1. So this tells us that the bond is polar, because our electronegativity difference is greater than 0.4, but less than 1.69. Okay, so we know that a sulfur and oxygen bond is polar, but if we look at our molecule, you'll see that all the dipole moments that point towards the direction of oxygen cancel each other out. So therefore, the SO3 molecule is nonpolar. And this is because the dipole moments cancel each other out. So we can compare the SO3 molecule with a molecule of SO2. If we were to find the total valence electrons of an SO2 molecule, again, sulfur has 6, oxygen also has 6, but this time there are 2 atoms of oxygen. And then we have a total of 18 valence electrons. And if we were to draw sulfur again as our central atom, and 2 double bonded oxygens, if we count out the number of electrons I have so far, I only have 16, so the remaining 2 will be a lone pair on the sulfur atom. So let's find out its Vesper shape. So this time our sulfur atom has 1 lone pair and 2 bonded atoms. So if we find out its Vesper shape, this tells us that when we have 1 lone pair, 2 bonded atoms, we have a bent molecular shape. And if we were to draw the same dipole moments going towards the direction of oxygen, since oxygen is more electronegative than our sulfur, then you can see that there is a net dipole moment going towards the oxygens. So this time, they aren't cancelled out, and therefore we can say that this molecule is polar. Is polar due to its structure and it has an overall non-zero dipole moment. Okay, so this is comparing SO3 and SO2 and why our SO3 molecule is nonpolar, whereas our SO2 molecule is polar. Okay, so the junior tutor said that the Lewis structure can give us an insight into whether a molecule is polar or nonpolar. For the molecule SO3, the sulfur atom will act as a central atom for the molecule with 3 oxygen atoms attached to it. There are a total of 24 electrons present, hence the Lewis structure of the molecule is written as... Okay, so this Lewis structure is actually incorrect because if we were to count out all the electrons in this structure, each bond containing 2 electrons, we have a total of 26. So this is actually the Lewis structure of SO3 2-, which is known as the sulfate ion. And you can see that the SO3 2-, sulfite ion, sorry. So this is the sulfite ion, and you can see that the 2 single bonded oxygens would give off a minus charge each, and this gives us 26 valence electrons. Then they said that it's trigonal planar, resulting in a zero dipole moment. So the explanation is correct, but it doesn't really make sense with the Lewis structure that they drew. So let me just say that okay, so I said the SO3 molecule is indeed nonpolar because it has a trigonal planar electron geometry and molecular geometry, with the dipole moments canceling each other out. However, the Lewis structure drawn is incorrect. There are 26 electrons in the structure, with the 2 single bonded oxygens containing a negative charge each. This is the Lewis structure of SO3 2-, which is the sulfite ion. Okay, so I'm going to say that this solution is incorrect, just because the Lewis structure is incorrect as well.